try to understand what object detection is all about. Now, in very simple terms, there are two concepts in object detection. The first one is about classifications or detection, or the second one is on localization. Now, what is this? Classifications, which you might already know, that in an image you're identifying whether that this is a bus, or this is a truck, or this is a person, and this is a bicycle. So that's about classification. The second is one of the most unique thing in object detection is what is called as localizations. So here localization would mean that not only you are trying to detect an object and identify what that object is, you're also finding where that object is in terms of creating a bounding box, and then you create a XY coordinate for this. So that's called localization, and this is one of the important feature which differentiates object detection from normal image classifications. So throughout this, in the course of this object detection, you will learn about different techniques. One is the object annotations, which we talked about when we looked at through the series. That is how to annotate an object, create your own data set through it. And then there is a lot of techniques for image pre-processing, how to build this bounding box localizations, image classifications. There are so many different techniques which comes into play in object detections. And so object detection is not something a new concept, and because you do it or you see it in your day-to-day life. Say for example, in identifying your face in a phone, or different applications which are there, which uses object detections, and it is widely used in different domains, be it through be it from security, or road safety, or defect detections in manufacturing plants, and so many different use cases for object detections. And therefore it's all the more important to learn about object detection, and this is what our endeavor is, to enrich you or equip you with a very important concept in computer vision. Object detection is not a recent phenomenon, or a new phenomenon. Ever since computer vision has existed, object detection in some form of the other has also existed. Now, some of the earlier techniques was predominantly based on manual extractions of features, and then using a classifiers to detect the object. So here there are two core processes, or you can call three core processes. One was the feature extraction. So for feature extractions, some of the earlier methods which were used were hog features, that is histogram of oriented gradient feature extractions, Haar feature extraction, Sift feature extraction. So with these methods, features were extracted, and then there was this process of localization. So for localization is when you have to detect a object within a bounding box. So for that localization also there were different methods used. We will see those pyramids and sliding window, etc. In the subsequent sections. So feature extractions, localization, and then classifications. So classifications was done by traditional methods like SVMs and random forest, AdaBoost, etc. So these were some of the earlier techniques which were used. But one limitations, or some of the major limitations of these methods were these didn't scale up to real-time detections. That is, if we have to do it for video, then these were not scaling up properly, and therefore there was this need for advanced methods. And when deep learning became more popular, a lot of methods in deep learning came into being, and one of the earlier ones, or one of the most prominent ones earlier in deep learning, was the RCNN family of object detectors. RCNN stands for region-based convolution neural networks. There are different versions of these RCNN things. One is RCNN, you have fast RCNN and faster RCNN. We'll be looking at these RCNN methods in post 3, and we'll be dealing with these also later. So after these RCNNs, or became popular. There was other deep learning techniques also became popular, like the old YOLO, the SSTs. And now transformers are also very predominantly used, especially vision transformers. So this is the overall evolution of object detection. Now let's go ahead and then look at some of these, a little more detail into some of these techniques, starting from the traditional techniques or the legacy techniques, and then also some of the deep learning techniques. Let's look into conceptually what these are in the subsequent slide. Let's look at the earlier methods which were used for object detections. One of the earlier method was the template matching method. Now, as the name suggests, template matching method is a very simple method, and conceptually this is what it's being done. You create a template of the object which you want to detect, and you slide it across an image. For example, look at this image, and you have to detect a pothole, and you create different templates of a pothole like this, and then you slide it across horizontally and vertically, and these locations where the pixel intensities of both the template and a certain location of the image, wherever it is higher, these are the places where it's highly probable to find a object which you're going to search. So this is the very simple method of object detections. Now, being simple, also these methods also had a lot of issues which came up. Say, for example, one of the bigger issues were the scale in which the templates and the images were being used. Now, if there is differences in the scale in which it is used, then there was these object detections also suffered. Along with it, the quality of the template also mattered. Now, if there was quality wasn't good enough, the template wasn't good enough, and still it affected the overall predictive power of this whole method. Now, having seen this, let's look at another method which is a little more advanced than this, and which has its foundation in some of our advanced methods also. So next we will look at image pyramids and the sliding window methods. We will now get into explaining image pyramids and sliding window methods. Now, image pyramids and sliding window method has got two different parts. One is the image pyramids part and the sliding window part. So let's first deal with the image pyramids. Now, in this method, it's like this. Let's explain this with an image here. Now, let's look at this layer one. Now, in this method, you have a window of fixed size. Now, what is the problem with this window of a fixed size? So this, with a window of this fixed size, it is able to detect some images or objects or these potholes at a certain locations here, at a further end. But the bigger potholes which are at the near end of the image it doesn't fit properly in that window, and then it just doesn't get detected. Now, to get over this, let's think of a way of progressively reducing the scale of this image, that is reducing the size of the image, and the window size remains the same, but you just keep on reducing the size of the image. So you can see that the size of the image is reduced from layer 1 till layer 7, and then you can see that more and more of these objects are getting detected with the same size of the the window. And this is the overall concept behind the image pyramids. That is, you scale these images progressively to different scales, and then you try to detect these objects. And why? And the image pyramids, the name comes from from the whole concept that if these different scale images are kept stacked vertically, it forms into a image pyramid. So that's the overall concept behind image pyramids. Now image pyramids are not implemented alone. Image pyramids are implemented in conjunction with a sliding window. So sliding window is a very simple method which we have seen, or similar method which we have seen in that in the template matching method also. So here the fixed size window is slid across both horizontally and vertically across the image, and then it tries to detect these objects which we have to detect. And along with it, along with the image pyramid, so you have the images which are scaled down progressively, and for each scale you slide across these windows and then try to find these objects. So the window sizes remains the same, and once you slide these objects, some of the potholes get detected and some do not get detected. And once you progressively scale down this image using the image pyramids, then a cross section of all these objects gets detected. And finally, these detection is again done through a classifier. Now, as and when these objects are or the images or the windows are slid across these images, it extracts those region of interest, for those windows, and then it goes through a classifier saying that whether there is an object which we want to detect or not. So based on a probability threshold, you determine whether there is an object there or not, and then if there is if it is beyond a certain probability threshold, we accept that there is an object, and if it is otherwise, we just reject that, and then we progressively scale the image down in different scales, and then the same process happens, and then you get a lot of regions of interest where the object is very likely to be. So that's the overall concept behind this. And after you get a lot of these regions of interest where there is a high likelihood of these objects, then you do a method called non-maximum suppression. That is, non-maximum suppression is basically to you will have to suppress these different bounding boxes. Now for the same location, you might have multiple bounding boxes there, and so non-maximum suppression is a technique wherein you reduce the number of bounding boxes so that you just have one or a very limited number of bounding boxes. Now we'll be implementing this image pyramids and sliding window in our post 3, that is in our when we build a object detector from scratch. So this is just a conceptual explanation of what image pyramids and sliding window methods are. Now we'll get into some of the advanced methods, the deep learning based methods like your RCNN, YOLO, and SSTs, etc. in the subsequent slides.